Okay, continuing with circles here, we've got chords and arcs. A chord is just going to be a segment whose endpoints are on the outside of a circle. So on the side over here, we've got the segment PQ as a chord. It doesn't go through, or doesn't have to go through the center of a circle. We have three kind of theorems that are all just kind of summed up with when I have congruent underlined central angles, chords, and arcs. They just all kind of go together. So if I have congruent central angles, that means I also have chords and arcs that are equal to each other. When we're doing this, so segment PQ over here on this in this example, segment PQ is going to be the actual line, and then if I wanted to talk about the arc, I could call it PQ, and then put the arc symbol above it. That would be arc PQ, which is talking about kind of going around the outside. That's the arc, and then in yellow, that's the chord. And so those three things go together. So below where it says congruent arcs, kind of write these things. So I've got central angles, go chords, and arcs. And so all these things go together. So in circles that are equal to each other, so circles that are congruent, same size, if I have central angles that are equal to each other, that means that the chords and the arcs also have to be equal to each other. If I have two congruent chords, that means the central angles and the arcs that go with that chord are going to be equal to each other. And then if I have congruent arcs in both the circles, that means that the chords and the central angles that go with that arc also have to be equal. So with the picture that we have here, I know that BC and DF are equal to each other. So BC and DF are my two segments. So that means that the central angles that go with the green segments that I just highlighted have to be equal to each other. So I know that angle BOC has to be equal to angle DPF. And again, central angles are going to be the angles in the middle of the triangle, central. And then the arcs have to be equal to each other as well. So these arcs right here, BC and DF, those are the arcs that go with that chord. So I know that arc BC is equal to arc DF. Okay, so those three things go together. They're interchangeable. Given the central angle, you have the other two. So next two theorems that we have, talking about chords being the same distance from the center. So if I have chords that are the same distance from the center of congruent circles, they're going to be equal to each other. The chords are equal to each other. Then the converse being that if I have chords that are congruent, they are the same distance away from the center. So with the first example that I have here, I've got congruent chords. So these chords are the same size, which means they have to be the same distance from the circle, so that means that x has to be 16 as well. With the one over on the right-hand side, in this one I'm given that they are the same distance away from the center of the circle, which means that the chords have to be the same size, so they're both going to be 12, which means that A has to be 6, so that the chords are both the same size. I'm actually going to skip the proof and I'm going to come back to it at the end because I would bore everyone to death. The next one, just three theorems, all kind of saying the same thing. So in the first picture, I have perpendicular, so a diameter is perpendicular to a chord. AB is my diameter, CD is my chord. So if it's perpendicular, it means that the chord is being cut in half. So go ahead and put a single line through. So I know that CE is equal to ED. The next theorem, if a diameter bisects a chord, so in here I've got that CE is equal to ED, that means that the chord and the diameter have to be perpendicular as well. And then the last one, perpendicular bisector of a chord, means that it has to go through the middle of the circle. So I've got a CD and AB are perpendicular, and AB bisects CD, So I know that that one has to go through the middle of the circle, so put a dot in there and name that O. So those three kind of all go together. So with this one right here, again, a lot of using the Pythagorean theorem. Since Kn goes through the middle of the circle and it's perpendicular, I know that these two, Ln and Nm, are equal to each other. So if the entire thing is 14, I know that just this piece right here ends up being 7. So I know that this is 7 there. So to figure out what my radius is, I can go 3 squared plus 7 squared is equal to r squared. Again, r is my hypotenuse because it is across from the right angle. And so I get 9 plus 49 is equal to r squared. So that gives me, what, 58 is equal to r squared. Take the square root of both sides. Should give me 7 point something. 7.6. Yeah, let's go just round to the nearest tenth, 7.6. Okay. Next two down, again, same thing. Remember that this BE right here is a radius, and so, again, the radius is the same all the way around a circle, so these two lengths right here are the same. So I can put my 15 here. Again, CB is going through the middle of the circle. AF is being bisected, and so I know it's a right angle. And so what I can do is, again, I can do Pythagorean theorem. I can say 11 squared plus y squared is equal to my hypotenuse, which is 15 squared. Again, there's my hypotenuse across from the right angle. I get 121 plus y squared is equal to 225. So I get y squared is equal to, see, 104. Take the square root of both sides. Square root of 104 gives me y is equal to 10 point, so it's going to round up to 10.2. Here, and so on the homework as well, since they put the 20 and the 16 kind of right where the line is, that means this entire length right here is 16, and this entire length here is 20. So I know that this piece is 10, just this piece right here is 10, and I know that just this piece right here is going to end up being 8. Again, it's perpendicular, which means that it is being cut in half as well. So I can, 10 is my hypotenuse, so I can go x squared plus 8 squared is equal to 10 squared. I get x squared plus 64 is equal to 100. So x squared is equal to 36. Take the square root of both sides, and so x is equal to 6. And then with the last one, again, kind of similar to the one that's right above it, 9 is my radius, which means that this is also going to be 9. So go ahead and put a 9 in there. The x is going through the middle of a circle, and so there's my 90-degree angle. 9 is my hypotenuse, so I'm going to go x squared plus 5 squared is equal to 9 squared. Go x squared plus 25 is equal to 81. So x squared is equal to 56. I can then take the square root of both sides, and that gives me that x is equal to 7 point... hold on a second. 7 point, so it's going to round up to 7.5. There you go. Okay. Go ahead and flip back over to the front side, and let's end with this proof here. So I want to prove that BE is equal to AE. Again, a lot of this just going back to proving that triangles are equal to each other. So what I can do is go ahead and draw a line from B to O and A to O. So my given, I'm given that AB is perpendicular to EO. So what I want to just prove is that those two triangles are equal to each other. And so with my second step, I know that the two radii are equal to each other. So I have AO is equal to BO. And I know this because radii are equal to each other. So this is equal to this. I know that EO is equal to EO. By the reflexive property. And so again, I have BO and AO are my hypotenuse. EO is a leg, and so I want to do hypotenuse leg. So I want to say that the triangles are both right triangles. So triangle BEO and triangle AEO are right triangles. Again, the reason why I said they were right triangles and not equal to each other is because I want to use hypotenuse leg, because I have the hypotenuse and the leg equal to each other. And so again, this is going to be definition of perpendicular, because the reason why I know is because I'm given that AB and EO are perpendicular to each other. So then I can say my triangles are equal, so triangle BEO is equal to triangle AEO by hypotenuse leg. And then last step is I want to prove that BE is equal to AE. So BE is equal to AE by CPCT. And that's it.